Hello students, welcome to the chemistry sessions. So I hope everybody has revised P block elements because now we are going to discuss about its exercise, CBSE pattern exercise. I've gathered 10 questions for you so that you are able to practice the entire chapter. So we have picked up reasoning as well as the reaction part, right? So let's start with the very first question of this round. So that is first question. So 1 to 3 question is of 1 mark, right? What is dry ice and why is it called so? So what is dry ice? So I had already told you about this, that is the carbon dioxide, the solid carbon dioxide basically, right? So it is solid CO2, right? And the question, this is very good and important one. Why it is called so? Why it is known as the dry ice? No, it doesn't mean that it does not have moisture, that is why it's known as dry ice, but actually it never passes on to the liquid state. See here, CO2 whenever it is solidified, right? See here, CO2 whenever it is solidified, it gets converted directly into the gaseous state, it sublimes, right? Without passing into the liquid state, no liquid state appears in between. And that is why the reason is it's known as the dry ice. Clear about it? So that was important question, right? I hope everybody has got it. It's just a simple reasoning. Now the next question, moving on to the second question I have, is boric acid a protic acid? Explain. So since this is an acid, you must be thinking that this is donation of protons, but actually this is not so. It is actually weak monobasic acid. Yes, we have discussed this. Now, so the answer would be no in this case. Why? Because whenever it does, first of all, we have to write that it does not give H positive. No H positive it releases, but it behaves as Lewis acid. Behaves as Lewis acid. Yes. Since it behaves as Lewis acid, that means it must be accepting the electrons. That means here comes up the boric acid, BOH whole thrice. It reacts with water actually, and what does it give? It gives BOH whole 4 negative, right? So that is the compound that is complex by accepting the OH negative from the water, behaving as a Lewis acid, not a protic acid, right? It's completely a different thing. And then it releases H positive in the ion, and that is why we call it as a monobasic, and it's weak, right? Not just it abruptly gives H positive, but we have to fetch it from it by adding up the water. Clear? So okay, let's move on then. So the next question, what does it say? What is Borik's bead test? I told you that this particular test is very important. Yes? And yes, you can get questions from this. Borik's bead test. First of all, what is happening? What is the reaction basically? So the reaction, I have got borax. Yes. We are heating it up. We get is puffy mass, right? We get puffy mass. All the water molecules are lost from the borax. And this puffy mass, if heated further, we get borax bead. Yes. And why we call it as a bead test? Why is that so? Because if we try to heat along with some of the very prominent oxides of ions, right? Cobalt oxide or chromium trioxide. So basically what happens is we get a blue colored bead, although it's a transparent one over here. But we get blue colored in the case of cobalt, we get green colored in the case of chromium beads, right? So that is a detection test basically. This bead test, it's a qualitative test to detect such ions in the compound. Clear about it? And yes, it has got reactions too that you have to write, right? I am not going to do it for you because we already have discussed that. Okay, let me just give you a slight idea. Na2 B4O7 dot 10H2O, we have to heat it up, and further you have to go. What is the borax bead basically? Borax bead is NaBO2 plus B2O3, the mixture of this, right? So basically it's a transparent liquid which solidifies. Clear? Okay. Now let's quickly move on to the question number 4. 4 to 6, 2 mark questions. Okay, so answer accordingly. Account for the following reasons. PbX2 is more stable than Pb. So it's a halide, lead dihalide and lead tetrahalide, right? So they are asking lead X2 and X4. This is more stable. Why? It's a simple reason. So here lead is existing in +2 state, here in +4. Now due to the inert pair effect, we know that +2 state is more stable, right? Going down the group, inert pair effect, reluctance of the s electrons to participate, thereby the oxidation state get reduced to +2. So that is more stable. Reason is inert pair effect. Yes? PbCl4 is less stable than SnCl4. We know this. Why? See here. So I have got here is chemistry sir gives silly problems. Yes? You remember the series? So down the group again the inert pair effect role play. So inert pair effect says whenever we are going down the group, +2 is getting more stable. Yes. So lead +2 state will be more stable as compared to tin +2 state. Yes. And lead +4 will be unstable as compared to tin +4 state. Right. So this is unstable. We can say that in here this is more stable and in here this is more stable, and we have got the answer over here. You can figure it out by this particular thing, right? So PbCl4 is less stable, we know this, inert pair effect, again the reason, and PbCl2 is more stable, again inert pair effect. Clear? Done. Now next question. So again the next question, question number 5 will be of 2 marks. Now complete the reactions, right? We have to write down the balanced. Balancing you have to do. Fine. Okay. NaH plus B2H6. Here is the reaction to form borohydrides. Borohydride. What kind of a borohydride is formed? Sodium borohydride, NaBH4, reducing agent, very good reducing agent. I told you about this. H3BO3, I need to heat it. Boric acid, I have to heat it. What do I get? I get is HBO2. What is this? Metaboric acid. Boric acid. Further heating it, we get B2O3. We call it as boric anhydride. We call it as boric trioxide. We call it as boric oxide. 3 names can be given to it. So that is what the entire reaction is. Aluminium plus NaOH. You know aluminium is amphoteric in nature. It can react with an acid. It can react with a base. So here it is reacting with the base, giving NaAlOH whole 4 negative. Fine. So what is it? It's sodium tetrahydroxo. This group OH is known as hydroxo whenever we are dealing with the complex, square brackets. So tetrahydroxo and finally aluminate. So no need to go into the detail that how we have got this name, because already you will be doing this in your 12th standard, right? There is an entire chapter about it. Special IUPAC naming is assigned to such compounds, such complexes. So aluminate 3. 3 is the state for the aluminium over here. Fine. Done. So this one is important. I told you about this. Whenever diborane is reacted with ammonia, we get the inorganic benzene. Fine. So basically what do we get is B2H6 dot twice of NH3. Fine. And actually this compound can be written as BH2 NH3 whole twice positive BH4 negative. So that is the entire compound which we have here. Fine. And yes, further heating we get B3N3 H6, that is the inorganic benzene borazine, right? Clear? And we are through with reaction number 4 as well, right? Clear? Now let me just drop this off and we'll be moving on to the question number 6 then. Question number 6, explain the amphoteric nature. I just told you about this, amphoteric nature of aluminium. So aluminium can be acting as an acid and a base. Here it is acting as a base. See here, I am reacting with an acid. It will be aluminium chloride, a salt is formed, right? Rest of the reaction you have to complete it on your own. Aluminium, if reacting with NaOH, we have just done this, yes? So here is a revision for you. Okay, so it will be NaAlOH whole 4, yes? So that is what we get. And these two reactions prove that over here it's acting as a base and over here it is acting as an acid. Clear about it? Okay. So done with the question number 6 as well. Now let's move on to question number 7. Now it is a very important question, important one. So we will be dealing some very interesting reactions over here, sort of a conversion it is, right? Although this particular level may or may not be going to asked in the exam, but yes, I have brought this question for you because it is very important, right? What all reactions we have did, it covers all of that. So first, they have given is starting from SiCl4, prepare the following, right? So we have to prepare it. From SiCl4, I need to prepare silicon, right? Can you tell me a reaction for that? So it's just a simple displacement reaction that we can have. See, SiCl4, if I try to react it with aluminium, we get Si. So basically it's a simple displacement reaction and aluminium chloride. Done? So first part we have done, we have prepared the silicon, right? See here, silicon has been prepared. Now linear silicone containing methyl groups. So we have done a polymerization in that case, yes, remember, for the preparation of silicones. And for the preparation of silicones, what do we need? We need actually is CH3Cl. Once we get the silica, and we already have got the silica, yes. So step number 1 will be this, step number 2 will be reacting this silica with methyl chloride. What do we get? Copper powder, yes, remember, approximately 570 Kelvin, and we get CH3 whole twice SiCl2, yes. Now reaction with water, 2 moles of water minus of twice of HCl, we get CH3 whole twice SiOH whole twice. Now there will be a polymerization with this particular compound, what I needed. So it will be something like this. Right? Are you able to do that? And so and so and so and so, blah blah. Loss of water molecule, we get a linear chain of it, right? Again, I am not going through the entire reaction, you have to do that. Na2SiO3 you have to prepare, right? So how you are going to do it? See here, so it's a very interesting kind of a reaction. So basically, I need over here is first of all silicon dioxide, right? If I try to prepare the silicon dioxide, then I'll be one step away from this particular formation, right? So what do we have to do over here is, I need to prepare SiOH whole 4 silicic acid, right? Silicic acid. Then by heating the silicic acid, I can prepare silicon dioxide, which then will be going to react with sodium carbonate and I get Na2SiO3, right? So how are you going to prepare the silicic acid? Do you know this? So it's very simple. We have done this before. SiCl4, which has to be given, reacting with water, we get it. Clear? And yes, this completes my part number 3 as well. Fine. So that was a very interesting question. We have used so many kinds of reactions in this. Starting with just one thing, right? One compound, we have prepared so many. Now, the next. So it's a very good question. A tetravalent element forms monoxide and dioxide with oxygen. So from the first line only, you have got the information that some tetravalent, that means a metal having +4 valency, it forms monoxide also, that means MO, as well as MO2. What is it? So we can simply see it is carbon. It is tetravalent, definitely it forms monoxide, it forms dioxide, right? But let us just check whether we have assumed it correct or not. When air is passed over heated element, producer gas is obtained. Now my information has been confirmed. That means carbon plus O2 plus N2 at 1273 Kelvin, what do we get? We heat it up, we get is the production of carbon monoxide with N2, and this is nothing but the producer gas. Yes? So I am confirmed with it that this is the carbon. Now, monoxide of the elements is powerful reducing agent. We know that this carbon monoxide is a powerful reducing agent. Yes, you know that. And it's used, see here, reducing agent, and reduces ferric oxide to iron for the extraction of metals. Remember? So it's like this. Fe2O3, we get is Fe plus CO2. Remember or not? And write the chemical equations. They want the chemical equations. Fine. And we have got the chemical equations. You just need to balance them. Clear? So that was a pretty good question. Now the next one, question number 9th. Now, what happens when borax is heated strongly? We know this. Borax bead is formed. Yes, we already have done this. Boric acid is added to the water. We already know this. We have just studied its nature, its monobasic nature. So we get is this. Fine. Aluminium is treated with HCl. Since this is amphoteric, we get aluminium chloride. Clear? Done with this question? Yes, you have to write the entire reactions with all the names of the compounds formed. Fine. Next, the last one, and yes, this is a very important question. Mark this as important because we will be discussing several reasons over here. Fine. TL, what is TL? Thallium. Thallium plus 1 state compounds are more stable than thallium plus 2. What is this? Baguette. Remember this? So down the group, inert pair effect, yes. Due to the inert pair, plus 1 is more stable than plus 3. Done. First part done. Why plus 1 is more stable? Clear? Now, the second one is very important. Carbon dioxide is gas while SiO2 is a solid. What is the reason behind it? See here, carbon dioxide, this is SiO2, this is. So the answer lies, why they are saying that this is solid and this is gas? Answer lies in the structure. The structure of carbon dioxide, you know, you see here. Both of them are covalent. But the thing is, it forms a 3D network. We already have studied that. Yes? Now, since this is an entire 3D network of covalent bonds, having so much of covalent bonds, so just like a diamond, it has got so much of strength, so it exists as solid. Whereas this exists, there is no as such covalency between the various carbon dioxide molecules, various interaction, no interaction is there. So that is why it is existing as a gas, whereas that as a solid. Done. So that was important one. Mark this as important. Aluminum chloride exists as dimer and BCl3 does not. What could be a possible reason? So since dimer, what is a dimer? Like this. So that is basically a dimer. That means two AlCl3s are getting combined, right? That means Al2Cl6. Whereas BCl3, it does not exist as B2Cl6, right? It only exists as BCl3. Why? It's simple. Due to the smaller size of boron, it cannot accommodate so many chlorines over here, right? So that is why it's not existing as a dimer. So that is a very simple reason of that. Clear? Next one, D part. It's important one, right? So basically not as such this particular reason has been provided in NCERT, but I wanted to pick this question because I found this important. Fine. BF3 is a Lewis acid, less Lewis acid. That means this is less acidic than BCl3. First of all, why they are behaving as acid? See here. BF3 I have got and BCl3. If you try to compare the two, if you try to just find out they both are electron deficient, they will be accepting the electrons. Fine. So they are behaving as Lewis acids. First thing. But which one is more acidic? How can we find out? See. B, F, right? I am just making a connection with only one fluorine, right? Here is the fluorine. Fluorine has got extra electrons. We know this, that the fluorine has got extra lone pair of electrons. Fine. So in order to compensate the deficiency of boron, you know, this fluorine can also try to donate the electrons, the extra electrons. So somewhat fluorine is being generous. So basically why there is a donation happening? It is also a 2p orbital and it is also a 2p orbital. So there is energy match. Energy match of two orbitals, yes, and due to this energy match the electrons can get transferred, and that is why this particular phenomena which you see is known as back donation. Back donation, that from the back side the fluorine is itself donating the electrons, thereby curbing its electron deficiency. Fine. So that is why this is having less of deficiency, but whereas if you see over here in BCl3, what is happening is, although it has got lone pair of electrons, but the orbitals here, right? See, chlorine is 17, 1s2, 2s2, 2p6, 3s2, 3p5. This is, right? So this is 3p, this is 2p, fine. No energy match. That means the donation will be difficult, right? Back donation of electrons difficult. Since this back donation of electrons is difficult, that means the deficiency of boron is still there. It's still deficient, still behaving as a good Lewis acid, whereas this will be having less of deficiency, so less acidic. Clear? So that was important one. I hope everybody has got it. I have just told you a slight idea about it, so just keep that in your mind. Fine, that is it. Now that was the D part. If I come on to the very last part, boron does not form B+3 ions. Why is that so? This is important. Boron is 2,3, yes, capable of donating 3 electrons, but why it is not donating? Because boron is already so much small size, it has got so much of nuclear charge that it will not be capable of donating all the 3 electrons. That means 3 electron donation means first of all existing as B+. Now I have to remove one more electron from it. Imagine how much energy will be required. If at all I am able to fetch 2 electrons, then 2 plus charge. 2 plus charge plus so much of small size. I will have to provide enormous amount of energy to it so that I am able to extract that electron as well, which is energetically unfavorable. Yes, and due to these things, due to these problems, it does not exist as +3 state. It will be very unfavorable thing for it. Clear? So this completes my part number 5 as well. So I hope everybody has got each and every reason of it. We have not covered the entire thing because 10 questions are always little sufficient to cover the entire chapter, but yes, I have tried to pick up some very good questions for you, some very good reasoning questions for you which are frequently asked in the examination. So you have to go through it once again, revise it once again. Again, if you have doubts, you can reach out to me. Have a nice day.